E-learning with NUT Endomorder Science School, MENA.
Good morning, viewers. I'm by name teacher Odike Sunday Victor. I want to believe you are enjoying your stay at home. Please continue to stay at home, continue to stay safe. Today, we're going to be talking about something very interesting, and that is numeric and algebraic fractions. Today, we shall be looking at numeric and algebraic fractions. Numeric and algebraic fractions. So, what are fractions? A fraction is the part of a whole. A fraction is the part of a whole. It is made up of numerator and denominator. A fraction is the part of a whole, and it is made up of two key elements, which are the numerator and then the denominator. Then fractions can be classified as numeric fractions. Fractions can be classified as one numeric fractions. And a numeric fraction is a fraction made up of only numbers. A numeric fraction is a fraction made up of only numbers. And examples of numeric fractions are 2 all over 4, 3 all over 5, 1 all over 7, and so on. These are examples of numeric fractions. Remember, I said numeric fractions are fractions made up of only numbers. Numeric fractions are fractions that are made up of only what? Good. Only numbers. Let us quickly look at how to add, subtract, and multiply numeric fractions. That is addition, subtraction, and multiplication of numeric fractions. Example number 1. Add 3 all over 5 and 1 all over 4. We have two different fractions here, and the fractions are 3 all over 5 and 1 all over 4. We are expected to add these two fractions together. Let us look at the steps which we need to take to solve this problem. The first step is to look for the LCM of 5 and 4. Remember, the denominators of these two fractions are 5 and 4. 5 is the denominator of the first fraction, while 4 is the denominator of the second fraction. So we look for the LCM of the two denominators, which are 5 and 4. Of course, from our last class when we talked about LCM, we know that the LCM of 5 and 4 is equal to 20. So having gotten the LCM, the second step or the second thing you need to do is to write the two fractions in such a way that they have the same denominator. That is, write this 3 all over 5 in such a way that it becomes over 20, and then 1 all over 4 in such a way it becomes over 20. Write the two fractions in such a way that they have the same denominator. Let's look at it. Now, we have 3 all over 5 and 1 all over 4. We want to add these two fractions together. Now we have agreed that the LCM of the two denominators is 20. So you write your 20 here at the bottom and then rule a line. Then you ask, you pick the first denominator. How many 5, which is 5, how many 5 can you get in 20? Or in other words, 5 into 20. Or in other words still, 20 divided by 5. And that will give us 4. 20 divided by 5 will give us what? 4. Then that 4 multiplied by the numerator here, which is 3. 5 times 4 times 3 gives us 12. Look at it again. 20 divided by 5, 4. 4 times 3, that gives us 12. It means we are done with the first fraction. So we'll go to the second fraction. And the denominator of the second fraction is what? 4. So you ask, how many 4 can you get in 20? Or in other words, 20 divided by 4. 20 divided by 4 gives us 5. Then that 5 times 1. 5 times 1 is 5. So the two fractions, you've written them in such a way that they now have the same denominator. 12 plus 5 is equal to what? 17. Then your denominator is also here, which is 20. So it means that 3 all over 5 plus 1 all over 4 is equal to 17 all over 20. So basically, what we have done in the process of solving this problem was to first of all get the LCM. Then we now write the two fractions in such a way that they both have the same LCM. And then we added the numerators together because the question said we should add. And that was how we arrived at 17 all over 20. Let us quickly look at another example. Example 2 says we should find the sum of 7 whole number, 7 all over 12, and 4 whole number, 2 all over 3. Now, sum is another word for addition. So anywhere you are asked to find the sum of anything, it means you should add those two elements, or the number of, as the case may be. If you are asked to find the sum of anything, it means you should add those things together. Now, we have 7 whole number, 7 all over 12. This type of fraction is called a mixed fraction. So this is also a mixed fraction. Now, this is a mixed fraction because it has a whole part and a proper part. This is a proper fraction and this is a whole part. This is a proper fraction and this is a whole part. So this is a mixed fraction. So the first step you need to take whenever you are to solve or you are to add fractions of this nature, the first thing to do is to change the mixed fraction to improper fraction. So in other words, we're going to change 7 whole number, 7 all over 12, which is a mixed fraction, into improper fraction. And then we're equally going to change 4 whole number, 2 all over 3, which is a mixed fraction, into proper fraction. Let's quickly see how to go about it. Good. We have a 7 whole number, 7 all over 12. Now to change this mixed fraction to improper fraction, what you do is that you pick the whole part. And the whole part here is what? 7. Pick the whole part and multiply it by the denominator. And that becomes 7 times the denominator, which is 12. Now, remember, pick the whole part and multiply it by the denominator. That is 7 times 12, which is what we have here, 7 times 12. Then you now say plus the numerator. You add the numerator to the answer you've gotten from this place. So if you have 7 times 12, then you add the numerator to it. That is 7 times 12 plus 7. In this case, 7 here is the numerator. Then everything all over the denominator, which is what? 12. You repeat the same denominator that you have here. So it becomes 7 times 12 plus 7 all over the same denominator. So I have 7 whole number, 7 all over 12. When you want to convert it to improper fraction, it becomes 7 times 12 plus 7 all over 12. Then 7 times 12 gives us 84. 84 plus 7 is what? 91 all over 12. 91 all over 12. It therefore implies that 7 whole number, 7 all over 12 is equal to 91 all over 12. So we have succeeded in converting this mixed fraction to improper fraction. Then the second fraction is 4 whole number, 2 all over 3. We want to quickly see how to convert this to improper fraction. Remember, just like in the first case, we picked the whole part and multiplied by the denominator, and that is 4 times 3. Pick the whole part, that is 4, multiply by the denominator, which is what? 3. Then plus the numerator, which is 2. That is whole part multiplied by denominator plus whole plus numerator, everything all over the denominator. That is 4 times 3 plus 2 all over 3. Alright, 4 times 3 gives us 12. 12 plus 2, 14. 14 all over 3. So have it to be 14 all over 3. Therefore, it implies that for whole number, 2 all over 3 is equal to 14 all over 3. So we have succeeded in changing the two mixed fractions we were given into 91 all over 12 and 14 all over 3. Now remember, the question says we should find the sum of these two fractions. So we're going to add the answer we got here and the answer we got in this place, and that will give us our answer. Now, just like in the first case, we're going to look for the LCM of these two fractions, and the fractions are 91 all over 12 plus 14 all over 3. Now, the LCM of 12 and 3 is what? 12. The LCM of 12 and 3 is what? 12. So, since 12 is the LCM, you draw your line and write 12. How many 12 can you get in 12? In other words, 12 divided by 12. That will give us 1. That 1 times 91. 1 times 91 gives us 91. Then 3 into 12. Or in other words, 12 divided by 3. That will give us 4. 4 times 14 gives us 56. So we're going to add these two numerators together. 91 plus 56 gives us 157 all over the denominator, which is what? 12. So how many 12 can you get in 157? You can get 13 12, remainder 1 all over 12. So it means that 91 all over 12 plus 14 all over 3 is equal to 13 whole number 1 all over 12. Alright, let us quickly look at example number 3. Example number 3 says we should find the difference between 5 all over 6 and 2 all over 5. Difference is a mathematical term that denotes subtraction or minus. So, for us to be able to find the difference between 5 all over 6 and 2 over 5, it means we're going to do 5 all over 6 minus 2 all over 5. 5 all over 6 minus 2 all over 5. So first and foremost, we look for the LCM of the denominators, which are 6 and 5. So the LCM is equal to 30. So the LCM of 6 and 5 is 30. So 30 divided by 6, that will give us 5. 5 times 5 is 25. In other words, how many 6 can we get in 30? That will be 5. So 5 times 5, 25. How many 5 can we get in 30? That is 6. 6 times 2, 12. So, since 6 times 2 is 12, we're going to now subtract, because the question says we should look for the difference. Now 25 minus 12, that is equal to 13 all over 30. It therefore implies that 5 all over 6 minus 2 all over 5 is equal to 13 all over 30. Now let us quickly look at this example. Example number 4. Find the product of 10 all over 14 and 7 all over 5. Product in mathematics stands for times. Product in mathematics stands for times. And here we have, the first thing we're going to do is to multiply the numbers directly, because we do not need LCM here since it is product or times. So have it to be 10 times 10 all over 14 times 7 all over 5. Now look at it. 7 here, 1, 7 in 14, 2. So we have 2 here remaining. Then 5 here, 1, 5 into 10, 2. So you notice that at the numerator we have 2 remaining, then at the denominator we have 2 also remaining. That becomes 2 all over 2 is equal to 1. So it means that the product of 10 all over 14 and 7 all over 5 is equal to 1. So the product of these two fractions is equal to 1. Then let's take another example. 5 all over 6 times 2 all over 5. Now you see we have 5 here at the numerator and we have 5 at the denominator. We are asked to multiply these two fractions together. So this fraction here, this 5 here, can cancel these 5. So 5 here, 1, 5 here, 1. So we are left with 2 at the denominator and then 6 at the numerator. That becomes 2 all over 6. 2 in 2, 1. 2 in 3 in 6 is equal to 3. So it means that 5 all over 6 times 2 all over 5 is equal to 1 all over 3. Alright, let us look at this also. Algebraic fractions. Algebraic fractions are fractions made up of both numbers and alphabet. They are fractions made up of both numbers and alphabet. And examples of algebraic fractions are 2x all over 7, 8y all over 19, x all over 2y, and so on. So let's look at this example. Find the value of x in x all over 3 is equal to 7. X all over 3 is equal to 7. Now what we'll do is that we have x all over 3 is equal to 7. Now let's divide this 7 by 1. That becomes 7 all over 1. So that we have a fraction in the left hand side and a fraction at the right hand side. So when you have two fractions with an equality sign at the middle, all you need to do is just to cross multiply. So all you need to do is to what? Cross multiply. That is x multiplied by 1. Look at this line. Tell you that you have to multiply x by 1. That is x times 1 is equal to 3 times 7. And x times 1 is equal to x. And 3 times 7 is equal to 21. So it means that x all over 3 is equal to 7. The value of s in this expression here is equal to 21. Therefore, s is equal to 21. Let us also look at another example. That is example number 2. Solve 2x all over 5 is equal to 7. Like I said earlier on, you're going to write it as 7 all over 1 so that you have a fraction at the left hand side and also a fraction at the right hand side. I haven't done that. The next thing you do is to cross multiply. So we cross multiply. That becomes 7x times 1. 7x times 1. 7x times 1 is equal to 5 times 7. And 7x times 1 is equal to 7x. Then 5 times 7 is equal to 35. So since we have 7x is equal to 35, we are not looking for 7x, we're only looking for x. Therefore, we divide both sides by 7. And that becomes 7x all over 7 is equal to 35 all over 7. 7 will cancel 7 and then x is left alone. 35 divided by 7 is equal to 5. Therefore, it means that x is equal to 5 in this expression. Alright, listeners, this is your take-home assignment. I'll be looking forward to receiving your solution in no distant time. So thank you for your time, and should you have any question or any comments, you could always get me through the school email. Thank you and bye for now till I hear from you.